Hello everybody, welcome back to another video of the system design playlist. In this video, we are going to discuss about rate limiting algorithms. First, we will discuss why we need rate limiting. Why do we actually need rate limiting? Then there are certain types of rate limiting algorithm. First is token bucket, then we have leaky bucket, then we have fixed window counter, we have sliding window log, we have sliding window counter, and the final summary. First, let's discuss why we actually need rate limiting. What is the use of rate limiting? Why we need rate limiting? So, rate limiting helps protect services from being overwhelmed. Like suppose there is a client or there is a user who is putting so many requests to a single server. So, to avoid those requests, to avoid any kind of attack, we put rate limiting. Okay. So, rate limiting is a kind of safety measure for us. So in this video, we are going to deep dive into 5 of the most common rate limiting algorithm as we have discussed in the syllabus. So we are also going to discuss about their pros and cons and learn how to implement them. Now let's look at why do we actually need rate limiting. So suppose there is a client. Okay. This is the actual client. Okay. Suppose this is a client. And this client is putting so many requests. It is putting so many requests beyond the threshold, beyond the limit. Okay, the limit is suppose it is a limit of 5 requests per second, but the client is making around 10 requests. Suppose it is making a 10 request per second, so it is causing overload, it is causing a kind of attack, it can be a data breach as well. So the server is not able to handle all the requests. The server is not able to handle all the requests. This is termed as overload. Okay, this is termed as data breach, or we can say it can be a denial of service attack or a distributed denial of service attack as well. So that is why we need a rate limiting algorithm that says, hey, no, I cannot allow your 10 requests per second. So I can only allow, even if the client is doing 10 requests per second, I can only allow 5 requests per second at a constant speed, at a constant chunks. Okay, so we can only allow 5 requests per second to be processed by the server. So what we can do is the remaining requests will remain in a queue or any kind of a temporary storage, and we will process them in the next second. This is how rate limiting works. Now in this slide, let's discuss about the token bucket algorithm. What is a token bucket algorithm? So token bucket algorithm is one of the most popular, and it is one of the widely used rate limiting algorithm, which approaches due to its simplicity. Remember the word simplicity and effectiveness. So its approach is simple and effective. Okay, so this was the definition of token bucket. Now let's look at how it actually works. Imagine a bucket that holds token. Suppose this is the bucket which holds the token. This is the bucket which holds the token, and the bucket has a maximum capacity of token. It has a maximum capacity of token. Okay, so the tokens are added to the bucket at a fixed rate, means the tokens are added to the bucket at a constant speed. At a constant speed. And as already mentioned, it is a constant rate. Rate means number of tokens per second. Suppose tokens per second at a constant speed. So these are added into the bucket, and then when a new request comes to the rate limiter, when a new request comes, the token bucket is going to provide the token to the through the new request, and then the request is going to be processed. If the tokens are already available, if the tokens are already available in the bucket, okay, suppose there are enough tokens, then we are going to process the request because we have enough tokens to process the request. But if the tokens are not available, if the tokens are not available in the bucket, then we are going to drop the request if there aren't enough tokens. So if I talk about the standard definition, when a request arrives, it must obtain a token from the bucket. Okay, as I said in the diagram. So it must obtain the token from the bucket to proceed. If there are enough tokens in the bucket, the request is allowed. Otherwise, the request is not allowed if there are not enough tokens in the bucket. Now let's discuss about the code of token bucket algorithm. Then we will move to the pros and cons. So now I am on my computer screen, and as you can see, I have the token bucket code in Python. So what you have to do, you have to import the time, you have to define a class with the token bucket, and you have to give some parameters. You have to define, declare a self, and then you have to assign some capacity, and you have to pass the parameter, the rate of filling. So what is capacity here? Self.capacity. It is the maximum number of tokens. It is the maximum number of tokens the bucket can hold. Okay. And what is the filling rate? It is the rate at which the tokens are added, means the tokens per second. As I told you that there is a constant rate of filling. And then we have self.tokens, which means the capacity. So what is the current token count? We have to check that, and we have to start filling with a full bucket. Okay. We are starting with a full bucket here. Okay. So what is the last time that we have checked the token count? So we are also going to track that, and then we are going to define a method, allow the request. Okay. Which tokens are allowed and which requests are allowed and which requests are not allowed. As we have seen, if we have enough tokens, we are going to allow the request, and if we don't have enough tokens in the bucket, then we are going to discard the request from the user. So this is the method for that. And then we are going to check if we have enough tokens for this request or not. If the tokens are greater than the actual limit, okay, greater than the required tokens, so we are going to return true, and we are going to reduce the tokens from the bucket. This is how it works. And if the tokens are not enough, we are going to return false, and we are not going to allow the request. So we are going to pass a capacity of 15, and the filling rate is 1. And suppose the filling rate is 1 and the capacity is 15, which means the maximum capacity of the bucket. And suppose we have provided a range of 20, and then we are going to call the allow request method. So this will print true for the first 10 requests, and then it will print false. So now let's try to check it. Before getting to the output, let me also show you that this is the time sleeper we have mentioned, so that we wait in between the request. First request is processed, and then we are going to wait for 0.1 second, and then the next request is processed, and then we have a time sleep again until the bucket gets refilled. Okay. And then finally we are going to return true, that all the requests are processed. Now we are going to return true. So let's try to run this. Okay. So I have provided a range of 20. Okay. So I will be seeing 20 outputs. Okay. So let's check the first. Actually I have the capacity of 15, and so I can see that I am going to check that first 15 are going to get processed. Okay, I think so. Let's check it. So we have true, 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 and so on. Okay, let me reduce the range first. Let me reduce the range to 10, and let me provide a capacity of 5. Okay, the filling rate is 1. It's completely fine. Let me try to rerun this. Okay, so now I can see that I am getting true, 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 true. So 5 times I am getting true means there are about 5 tokens which I am processing. Means 5 tokens means I am processing 5 requests successfully, and then I am returning false, 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 and false. Out of 10, I am processing 5 requests, and then I am returning false, and finally I am returning true. Okay. True means that I am processing the request. I currently, like, according to the filling rate, I currently am able to process the request because I have the valid tokens in the bucket, and then I am finally returning the true because I am out of range here. So this is how it actually works. If I have token in the bucket, I am going to process the request, but if I don't have tokens in the bucket, enough tokens, I am going to discard. Simple. Now let's discuss about the advantages and the drawbacks of token bucket. So the first advantage is it is relatively straightforward, as you know that it is easy to implement and understand. Easy to implement and learn. So this is the first advantage of token bucket, and it allows burst of request up to the bucket capacity. So it can allow burst of request up to the bucket capacity. If the capacity is exceeded, it will not allow the burst of request. So it can accommodate short spikes. This is one of the advantage. Let's discuss about the cons. The first disadvantage is like the memory usage. Memory usage is high. Why it is high? Because the number of user, if it is implemented per user, so the memory usage is relatively high, and it doesn't guarantee a perfectly smooth rate of request. A smooth rate of request is not guaranteed. So these are the disadvantages of token bucket, and these are the kind of advantages of token bucket. Now let's discuss about the second one, which is leaky bucket algorithm. What is a leaky bucket algorithm? So leaky bucket algorithm is similar to a token bucket algorithm, but it focuses more on smoothing the outburst traffic. Okay, like we have seen that it was not allowing smooth request flow, but leaky bucket algorithm is going to achieve that. So let's look at how it actually works, then we are going to understand. So the major advantage here is smoothing outburst traffic. Let's look at how it actually works. So imagine there is a bucket. Again, here is also we have a bucket with a small hole. Suppose there is a small hole. So there is a small hole below the bucket, and this is the actual bucket. Okay, so request enter the bucket from the top. This is a new request which is entering the bucket. Okay, and the bucket processes means it leaks. This is known, one leak means one process. Leak is equals to process. When the bucket leaks, it processes. Okay, so it processes the request at a constant rate. It processes the request the incoming request with a constant rate. Remember this definition. It processes the request, incoming request, with a constant rate. This is the bucket and this is the hole. So when there is a leak, it means it is processing a request. How it actually works? If the bucket is full, the new requests are discarded. This bucket is full. Okay, now it is doing an overflow. New requests are discarded. Okay, so now let's look at the flow. The new request is coming. Bucket is filled at a constant rate. We know that. It was also there in token bucket as well. So it is filled at a constant rate. Okay, and then the drop. One drop means one request is processed. Again, another drop means another request is processed. So over the time, the bucket leaks, which allow the further request. So when there is a leak, the new request is processed. When there is a leak, the new request is processed. When the bucket becomes full, means there is an overflow condition. So we are discarding the request. Means we are not allowing the new request. We are discarding the request. This is how the leaky bucket algorithm works. Now let's look up at the code of the leaky bucket algorithm. Okay, so now I am on my screen of Visual Studio Code. So what we need two packages. I am importing collections like import DQ, and I am also importing time because I need that. And then I am defining a class leaky bucket. I am providing parameters in the method init, which means self, capacity, and the leak rate. So let's look how it actually works. This part is almost same that we have discussed in the token bucket. This is almost same, but one thing is new. We have a DQ. It is a queue to hold the request timestamps. Okay, so don't confuse with that. Then we are defining the allow request. Okay, so we are simulating the leaking from the bucket here. Okay, and then if the leak is greater than 0, remove the leaked request from the bucket. Simple. And check if there is capacity and add the new request. If there is existing capacity, we can simply add the new request, and with the each and every leaking drop, we can process that request. But if there is an overflow, we are not going to allow that request. So we simply return false. And here, if the self bucket is less than the capacity, okay, so we are going to append it, means we are going to add the new request, and we are simply going to process it and return true. Suppose I have provided a capacity of 5, means I am going to provide 5 requests, and I am providing a leak rate of 1 request per second, and then I have a range of 10. Okay, so it will print true for the first 5 requests and then false. Now let's look at this. I have provided a time sleep, same for this, 0.1 and 1 here for the bucket to leak. Now let's try to run this and check the output. Okay, so I have the output now. We have first 5 true, and then we are processing it false because we are not processing the request. So before the final request, the bucket size is 5. Okay, and then finally we are returning true because we have reached the range. We have provided the range of 10. We have reached the range, or we have reached the limit. So now the bucket size before the final request is 5, and then we are returning true, means we have processed all the range, and bucket size after the final request is 4 here. So the bucket size is reduced. Okay, this is how the leaky bucket algorithms work. It is quite efficient if we compare to the token bucket algorithm. So it is providing a smooth functioning of the request. We are easily able to process the request, and there is no outburst here. Now let's try to understand the use cases, means advantages and the drawbacks of leaky bucket algorithm. So the first advantage is it processes the request at a steady rate. So it processes the request at a steady rate. Remember this word. And it prevent sudden outburst. It prevent sudden outburst. Remember this. It prevent it. Okay. And the second advantage is it provides a consistent and predictable rate of processing the request. Consistent and predictable rate of processing request. Okay, so the first disadvantage is it does not handle the sudden outburst of the request well. As we handle in the token bucket, it is not doing that, and access requests are immediately dropped due to overload or due to overflow. So access requests are dropped immediately. Okay, and the second disadvantage is it is slightly more complex to implement, and if we compare to token bucket, more complex. Okay, so this is what leaky bucket algorithm is, and how it actually works. We have discussed about the code as well, how the code works, and these are the pros and cons. Now let's move to another algorithm. Now let's discuss about the fixed window counter, how it actually works. What is the definition of a fixed window counter? So let's say with the help of diagram, before getting to diagram, let's discuss about the definition. So fixed window counter algorithm divides the time into fixed windows and count the request in each window. So what it do is it divide time into fixed window and the second is the count request. Okay, the count request is divided into each window. So it divides the time into fixed windows. What are the fixed windows? This is a fixed window. This is one fixed window here. Okay. And this is another fixed window here. This is another fixed window here. This is another fixed window here. Okay. And these are the count. This is count 1. This is count 2. This is count 3. So this block means count. And these are the windows. Okay. So here we have the request, and this is the actual time which is divided into windows. So we have to process only 3. We can only count 3, means we can, in a particular window, we can only process 3 requests. Okay. So here in a window, we can simply process only 3 requests. Okay. As you can see with the green sign, these are the requests which are served. But if the requests are exceeded, these are the requests which are discarded. But these are the actual requests which we are processing. So we can only process 3 requests in a particular timestamp. So at 00, we are processing 3 requests, and at 01, we are processing the 3 requests, but we are discarding the remaining one. And at 02, we are processing the 2 requests. Okay. And then 03, we are processing the 3 requests, but we are actually discarding this one. Okay. And then we are actually processing the 3 requests only. This is how the fixed window counter works. So that understand this. The first thing is, the time is divided into fixed windows, the 1 minute interval. So here we have taken a 1 minute interval. Okay. So the time is divided into fixed windows, and each window has a counter which starts with 0. Each window has a counter which starts with 0. Okay. And the new request increment the counter for the current window. Okay. If the counter exceeds the limit, the requests are denied until the next window. So these requests are denied until next window. When the count becomes greater than 3, here, these requests are denied until the next window. Remember this. So now let's try to code it out and check in the VS Code the output. Now I am over my Visual Studio Code, and here is the code of the fixed window counter. So you have to import the time, and then you are defining the class. This is the same part, I think, but quite different. We have the different variable name. Here window size is the size of the window in seconds. Okay. And the maximum requests are the maximum number of requests each window can process. Okay. Then we are defining the allow request. So this is the method. So the first thing is, if we have moved to a new window, if we are moving to a new window, reset the counter. Okay. Reset the counter again to 0, and then start from that. Check if we are still within the limits of this window or not. If we are still in the limits of this window, then that means we can process the request, and we can simply return true. Means we can easily process the 3 requests, but we cannot process the further overflow request in that particular window. But if the limit exceeds, like we have seen in the diagram, the limit was exceeding, count was greater than 3. So we were returning false, means we are discarding those requests. Here is an example. Suppose the window size is 60 and the maximum request is equals to 5. Means a window can process a maximum of 5 requests, okay, per minute. A particular window can easily process 5 requests. Okay. Then we are going to call the allow request, and there is a range of 10. Let's try to run this and check the output. Okay, so what it do is it is going to print true for first 5. These are going to get processed, means these are going to get processed in the window, but the exceeding one are not going to get processed, means these are going to get rejected. This is how it actually works. Now let's discuss about the sliding window log. This is the next algorithm we have to discuss in the rate limiting. So a sliding window log algorithm keeps a log of stamps. It keeps a log of timestamps. So how it keeps a log of timestamps? It keeps a log of timestamps for the request. It keeps a log of timestamp for each request. For each request. Okay. And it uses this to determine if a new request should be allowed or not, if it should be served or it should be rejected. Now let's try to discuss about it, how it actually works. So the first thing is it keeps a log of request timestamps. The second thing is when a new request comes in, when a particular new request comes in, it removes all the entries of older than the window size. All the requests which are older than the window side, it removes that entry. It removes those particular entries because we are using a sliding window. So the window is actually sliding this way. Okay. And it is contracting its size. It was previously like this and now it is like this. It is here. Okay. So we are actually using a sliding window here. The sliding window, this part is the sliding window. Okay. So now what we are doing is we can easily serve these requests. We can serve as these many requests, but if the requests are exceeding, we are going to discard them. Okay. These are the rejected ones. It count the remaining entries as well. Okay. It count all the remaining entries. If the count is less than the limit, it allows the request and add it to the timestamp of the log. Okay. If the count exceeds, so here the count is exceeding. Here 5 is greater than 3. We cannot allow it. Okay. So the count is exceeding and request is denied. These are the requests which are rejected. So we can only allow according to the count. If it is less than the count, we can simply allow it. If it is greater than the count, we are going to deny. Okay, this is how it actually works. And we are also keeping a fixed current window here, and we are keeping moving here. So this windows expand on the right side and contract, and then again expand and contract based on the timestamps. Now let's discuss about the code part of the sliding window log. This is the actual code for the sliding window log problem. Here we have the class of sliding window log, and then this is the same part. We are using a dequeue to log to keep the track of the request timestamps, and then we have allow request. Okay, if the request log is less than the maximum request, we are going to return true, and we are going to append the request. We are going to add it. If it is not true, then we are going to return false, means we are discarding the request. So here we have, suppose the window size is 60 and maximum request per window we can allow 5 requests per minute, and then I have a time sleep here. We have a range of 10. If we try to run this, this is how it actually works. The 5 requests are processed successfully, and then we are returning false. And after that, we have a time sleep of 60. So we are going to wait for the window to slide. Then my window will slide, and I will be able to see that I can only process the requests which are less than the previous count. Okay. So if it is it becomes greater than the count, means I have to discard all those requests in the particular timestamp. This is how it actually works. Now let's try to discuss about the pros and cons of sliding window log. So what are the benefits of sliding window log? It is very accurate. Why it is accurate? Because there are no rough edges between the window. I can easily track my window. Okay. And I don't need to worry about it. So it works well with low volume API. It works well with low volume API. What are the disadvantages? So it can be memory intensive for high volume API. Memory intensive for high window API. High window nahi, I think it is high volume API. Okay. The second disadvantage is it requires storing and searching through timestamps. It requires storing and searching with the help of timestamps. So these are the disadvantages and these are the advantages. Now let's discuss about the sliding window counter. This is the one of the most important algorithm in the rate limiting, and this is most famous algorithm, most efficient as well. So it is quite efficient. What is the sliding window counter? So this algorithm combines the fixed window counter and sliding window log. It is a combination of fixed window counter and sliding window log. Let's look at how it actually is a combination of sliding window log and fixed window counter. So it is more accurate and more efficient. Okay, here let me add accurate as well for your understanding. And instead of keeping track of every single request timestamps at the sliding log does, it focuses on the number of requests from the last window. So what are the number of requests coming from the last window? It is focusing more on that. Suppose these are the 25%, means 25% requests are from the last window, and these are the requests from the new upcoming window. Okay. So if you are in 75% of the current window, these are the current window. Okay, and 25% of the wait would come from the previous window. This is the previous window. Okay, let's try to understand with the help of previous and current. So here the wait is equals to, here the wait is equals to 100 minus 75% multiplied by last window request plus current window request. Last window request plus the current window request. Okay, so now when a new request comes in, when a particular new request is coming in, you add 1 to that wait. Okay, wait plus 1. So what you are doing is you are doing wait plus 1 when the new request is coming. If this new total crosses our set limit, if this is going to cross our particular set limit, we have to reject the request. So it is crossing the set limit, like 1 2 3 4, we can allow the 4, but we are going to discard the 5th one. So this is reaching to an exceed, and it is exceeding, and then we are rejecting that particular request. So let's try to run this more well, how it actually works. Let me try to erase this. So we know that it is a combination of fixed window counter and sliding window log. So this is the previous. Okay, this is the previous and this is the current here. Now let's try to understand how it actually works. First is it keep track of request count for the current and previous window. It is keeping track of current count and previous window count. Okay. Also, the second thing is it calculate the weighted sum of requests based on the overlap with the sliding window. As we have seen the formula, it is doing a weighted sum of the request, like weight is equals to 100 minus 75, and then we are doing something like modulo. Okay, this is the percentage, and then we are going to multiply with the last plus the current. Okay, this is how we are going to find the weight. So this is the formula to find the weight. Remember this. The second thing is, like, we have to calculate the weighted sum of the request based on the overlap with the sliding window. So here we have a overlap. If the weighted sum is less than the limit, if the weighted sum that we have found is less than the limit, we can allow the request. Okay, we can simply allow the request. If the weight, or we can say weighted sum, is less than the count, we can simply allow the request. If it is greater than the count, we are going to reject that, because those requests can't fit in our current window. Those requests cannot be fit in our current window, because our current window has a limit of, it has a limit of 5. Okay, it has a limit of 5, so we can only allow 4. We cannot allow equals to 5 and greater than 5. Okay, we can only allow 4, a 25% from previous one and 2 from the current one. Okay, and in the 75% we are discarding this particular one. So this is how the sliding window counter actually works. Now let's try to code it out. Now I am on my screen of Visual Studio Code. Let's try to discuss that, how it actually works. So these are the same. We have the window size, we have maximum requests that we can allow per window, and then we have the window size here. So I have two new things here. I am doing a request count, okay, and then I also have a previous count, and then I am going to define the allow request method. If we have moved to a particular new window, then we are going to update the count. We are going to increment the count. Okay, so calculate, and we are also going to reset the count. Okay, so the request count is going to reset, and the current window is equals to the window itself. So calculate the weighted request count. Here we are calculating with the help of formula that we have discussed. So check if we are within the limits, if the weight is less than the count or not. If it is less than the count, we are going to simply return true, and we are going to process the request. After that, we are going to increment the count, okay, for the next request. And if it is not true, we are simply going to return false, means the count, it is greater than the count. So we are overloading here. And here, suppose I am passing a window size of 60 and the maximum request that can be processed per minute is 5. Then it will simply print true for first 5 requests and gradually becomes false. Let's try to run it. Okay, so as you can see in my terminal, it is returning true for the first 5 requests, and then it is particularly returning false for the others, and it is taking time because I have provided a timestamp of 30 seconds. So it will simply wait for that, and then only it will reset for the next window. This is how the sliding window counter actually works. This is the most efficient and accurate algorithm in our rate limiting algorithms. Now let's discuss about the advantages and drawbacks of the sliding window counter. So the first advantage is it is more accurate. It is more accurate. Okay, it is more accurate than fixed window counter, and it is also more accurate than sliding window log. So we can say that it is more accurate than fixed window counter. And the second thing is FWC stand for fixed window counter. The second advantage is it is more efficient, more memory efficient than sliding window log. Okay, so in terms of speed, it is more better than fixed window counter, but in terms of memory, it is more efficient than sliding window log. Okay, the third advantage is it is going to smooth all the edges. Like we have seen in the fixed window counter, what it was doing, if there is an outburst or there is any peak traffic on the windows edges, so we are not handling them and it may cause a drawback, but we are easily handling the edges here, so there is no drawback. And the first drawback is it is slightly more complex to implement. This is the only drawback of sliding window counter. It is more complicated or more complex to implement. So when we are implementing a rate limiting, what we have to consider? We have to consider factors such as scale of your system, how much scale of your system you have, the nature of your traffic patterns, like whether it for example, the traffic usually increases on Friday, or it may reduce on Monday. Okay, so when the traffic is suppose there is a peak load time. So if the peak load is greater when we consider around 1 o'clock, because we have like free time there, and it is more at night if we compare to the daytime. Okay, so we have to check what are the traffic patterns as well, and we have to understand the granularity of control that we need. Thank you guys, this was all about today's video. I hope you guys like this video. Do like, share and subscribe my YouTube channel Code Money. We'll see you in the next video. Till then, take care. Bye.